All right, here we go. Doing some stoichiometry. Today in class, we learned about multiple problems. Tonight, it's time for Math to Math in your very first do-at-home notes. Yay! All right, so problem type 1 was a one-step. Had a nice little formula. It's you can memorize the fill in the blank skeleton or just think about it linearly. The same goes true with the math to math, but we're going to have 3 whole steps. And that's going to be in 1 second, because let's review mole-to-mole really quick. Here's our mole-to-mole. Here's our skeleton equation. This is what you needed to memorize if you're a memorizer. Otherwise, you need to just know how to do it. We talked about mole ratios today in class. We had first example, second example, and now the new stuff. Here we go. So, math to math problems are going to be 3 whopping steps. Again, it's going to be a word problem. First thing you do is write the balanced chemical equation. Second thing you do, figure out the problem type. If it's math to math, they give you grams and ask for grams. So it's a grams to grams problem. Grams to grams problem. You're going to perform dimensional analysis using your balanced chemical equation. That would be your mole ratio that you learned today. Mole ratios, again, allow you to turn moles of A, what they give you. A is always what they give you. How about what's given? Into moles of B, what they want. Wanted. Oh, be wanted. How cute. Okay. We use the periodic table to turn from moles to grams or grams to moles. We've done that before. We've done that before a lot. We know how to do that, so that part's good. So, if you like to think about things linearly, here's your linear pattern. We go from grams of A into moles of A. Then we turn moles of A into moles of B, and then moles of B into grams of B. Here's our skeleton equation. So if you're a memorizer, here's what you're memorizing. This is going to be on the quiz tomorrow. So make sure you absolutely must memorize it for your quiz tomorrow. So write that down. Pause if you need to. I'm going to keep on going. Woo! All right, here's our first example. Notice they ask for a mass. Mass is always in grams. Of carbon dioxide, we know what carbon dioxide is. It's CO2. Is produced, so carbon dioxide is going to be a product when 10 grams, they gave us grams of glucose, which is C6H12O6, combusts. So, first, we need to write a balanced chemical equation. Write balanced chemical equation. Pause and write your chemical equation now. All right, here you're back. Let's write the chemical equation. You should have C6H12O6. It's combustion. You need to have oxygen to light stuff on fire, making CO2 and H2O. It's on fire, so everything's a gas. Sugar's a solid. We knew that. Let me put in my parentheses, and then we're going to balance the equation. So we have 6 carbons. We need 6 carbons. We have 12 hydrogens. We need 12 hydrogens. And now we've got 6 oxygens taken care of. We have 12 more to go. So we've got 12. Okay, so my coefficients are 1, 6, 6, and 6. Okay, that's my first step, writing my balanced chemical equation. Second step, here's my skeleton. It goes like this. Grams of A, goes always 1 mole of A. All right, in the middle is our mole ratio, with moles of A over under moles of B, and 1 mole of B on the bottom, grams of B on the top. And my answer is always in grams of B. Okay, so what's A? A is what they give you. They gave us glucose. They gave us 10.0 grams of glucose, which is C6H12O6. So everywhere I've got A is C6H12O6. 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 Hold on. H12O6. Okay. Now, what mass of carbon dioxide? Carbon dioxide, CO2, that's B. So, CO2, CO, oh wait, let's do another color. That's a great idea. Okay, how about green? So, CO2, 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 and CO2. Now, did you have to write B and then write CO2 over top of it? No. But that's what I'm doing to show you that we've got our B here, which is CO2, CO2, and CO2. Now, another thing you should notice is that the equation starts off with the same chemical. I put glucose in red and our carbon dioxide in green. So notice it goes red, 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 and then green, 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 green for our chemicals. Maybe that makes sense, maybe not. We'll talk about it tomorrow if it doesn't, but there is a pattern here. Look for the patterns because the patterns help you learn stuff. All right, so we've got some more numbers to fill in. Grams. Grams always come from the periodic table. So here's some grams, and there's some grams over here. Grams always come from periodic table. Grams come from periodic table. So we find the mass of C6H12O6. So that's going to be 6 sugars, or 6 carbons. I'm getting my calculator ready. So 6 times 12.01 plus 12 times 1.01, the mass of hydrogen, plus 6 times 16, the mass of oxygen, for a grand total of 180.18 grams. All right, second, we've got our mole ratio. Our mole ratio comes from the balanced chemical equation. So here's my mole ratio. Mole ratio from balanced chemical equation. And the coefficient on CO2 is 6. The coefficient on C6H12O6 is 1. So there's my mole ratios done. Last, I need my mass of CO2. So carbon is still 12.01. And oxygen is 16, and there's 2 of them. That gives me a mass of 44.01. 44.01 grams. So in my calculator, I'm going to do all this math to get my final answer, which is going to go right here in this beautiful box. So 10.0 divided by 180.18 times 6 times 44.01 equals 14 point blah blah blah. I get 3 sig figs in my answer, so 14.7 is my final answer. So I'm going to double check that really quick. So 10 divided by 180.18 times 6 times 44.01. Yep, 14.7. That's my first example. Okay, one more example. How many grams of gold are produced when lithium reacts with 20.3 grams of gold phosphate? And the charge on gold, AU, is +1. Same 3 steps. First, write your balanced chemical equation. Second, problem type. Third, set it up and get your answer. All right, so write your balanced chemical equation on your paper right now. Pause it. But I'm going to do it anyways. Here I go. Gold is AU. Lithium. Oh, whoops. Look at that. Gold is produced. So let me start over. So gold is produced when lithium's Li, reacts with AU3PO4. Single replacement reaction. Is lithium higher than gold? Why, yes it is. Gold gets kicked out. Lithium hooks up with phosphate, which we don't approve of, but whatever. Swap and drop. And balanced chemical equation, done. Try setting up your math problem on your paper right now. Go. And I'll do it too. So 20.3 grams of AU3PO4. Giant parentheses. And it's a 3-stepper because we've got grams to grams. And of course I ran out of room. So first, cross cancel. AU3PO4. 1 mole on top. Mole ratio, 1:1. 1 mole AU3PO4. 1 mole AU. 1 mole AU. And we'll turn that into grams of AU. All right, I need my periodic table. All right, so gold is 197.0. 197.0, and there's 3 of them, times 3, plus phosphorus at 30.97, plus 16 plus 16 plus 16 gives me 669.97. That seems a little bit big. Not really. 669.97. Okay, I'm going to double check that anyways. So 3 times 197 equals plus 32.07. That's wrong. Clear. 197 times 3. 30.97. 16, 16, 16. Okay. Oh, there's 4 of them. Oh, crap. All right. I have solved my calculator issues, and the mass of gold phosphate is 685.97. Sorry for any confusion right there. The mass of gold is 197. 197.0 according to my periodic table. Okay, so now I get to crunch my numbers. I get 20.3 divided by 685.97 and then times 197. Gives me 5.829, blah, blah, blah. I get 3 sig figs. So 5.83 grams of gold is my final answer. Sorry about the confusion. We'll have more examples and practice tomorrow in class. I will see you then. Good night.